Hello. Okay. Here we're going to discuss about permutation, combinations, and counting principle. So, in the beginning of that, you can think of essential questions. So, what can be the questions over here? So, what's the difference between a permutation and combination? And when do we use the counting principle? Can you find the total number of outcomes? So, keeping this in mind, we will proceed further. Okay, so let's have few examples. So with the help of these examples, we will try to understand the concept. So here, it's a permutation or combination, you can decide. My fruit salad contains grapes, pineapples, strawberries, and blueberries. Does it matter what order I place the ingredients in the bowl? And which one is it? What do you think? Okay, so here it is a combination since the order that you're gonna put the fruit in a fruit salad does not matter, so you do not count the repeated events. So the grapes, pineapples, strawberries, blueberries is the same as if you're putting blueberries, strawberries, pineapple, or grapes. So basically here we are looking for how we can find combinations, but even in the combinations then we will see how these events are happening, and based on that we can decide whether it's just a combination or it's a permutation for that. Now the next one, permutation or combination. Again, my local combination is 23 5 17. Does it matter what order I turn the numbers? And which one is it? So think about it. What do you think? If you will changing an order for this one, will your locker be open? Definitely not. So it's a permutation. Another set of numbers in a different order will not open your locker. So the order does matter. So 23 5 17, a combination is very different than 23 17 5 or any other set of these three numbers. So here so far in two examples, so what can we conclude out of this? So if it's a combination, so the order does not matter, but if it is a permutation, then order does matter. Okay. Here, counting principle. So counting principles involve outcomes with different categories similar to a tree diagram. So for example, you are making a password for your computer. You will use two letters and one numbers. Repeats are allowed. So you have different categories. It's gonna be letter, number. So let's say 26 times 10, because how many letters are there? 26 letters are there. So out of these 26 letters you will choose any letter. Again you have a choice of letter over here, so you're gonna choose one letter, but out of 26. So how many choices you have to choose a letter, which is 26 again. And then the numbers you can choose from 0 to 9. So these are 10. So the total possible outcomes will be 6760 in this case. Okay, let's have a look on example for combination. Pick a team of 3 people from a group of 10. So how many outcomes are possible? So here it's a combination since the order that the 3 people are selected does not matter, because you did not set like this person should be on the first place or second place or the third place, because here we don't have any order, so we can choose random people. Okay, out of we can choose 3 random people out of this 10. So that's mean we can write this as a 10C3, and you remember the combinations, actually binomial theorem when we were discussing. So at that time we have discussed about this. So we learned if it is NCR, so it will be n factorial over n minus r factorial times by r factorial. So in this case, so since it's a 10C3, So it will be 10 factorial over 10 minus 3 factorial times by 3 factorial. So here we know that 10 minus 3 factorial cancels 7 and below. So that's mean 10 times 9 times 8 over 3 times 2 times 1. So here we will get the total outcomes will be 120. Or even you remember, like, you can use your calculator simply. So you can press 10 followed by a combination key and then 3. So at that time you will come up with this answer as a 120. Now here, permutation one. So pick a president, a vice president, and secretary from a group of 10 people. So here in this case, you have to see, you're gonna deciding a president, vice president, and secretary. So order matters because the position of president is higher than the vice president or secretary. So that's mean this is gonna be permutation. So 10p3, so the general formula for this one is n factorial over n minus r factorial. So this is 10 factorial over 10 minus 3 factorial. So we know that 10 minus 3 factorial cancels 7 factorial and below. So 10 times 9 times 8 over 1. So this will give us 720 outcomes. Okay, now try this one. How many ways can 7 students finish a race in first, second, and third place? Okay, so here the quick question you can ask yourself, you can look into it whether the order will matter or not. So if you can get the answer for this, definitely you are already decided which one to use. Yeah, so you decided. Okay, so it is a permutation. Why? Because you would rather win the race than finish in the second or third place, because 7p3, the total number of people are 7, and the first, second, or third place, so that means 3 places we are gonna decide. So 7 factorial over 7 minus 3 factorial. So we know that 7 minus 3 factorial cancels 4 factorial, as you remember, like uh, we did this. So here 7 factorial can be expanded to 7 times 6 times 5 times 4 factorial over 7 minus 3 is 4 factorial. So 4 and 4 factorial will cancel out. So this will give us 210 possible outcomes. Okay, or you can use as a counting principle, because if you look into it, there are 7 people. So the first position, whoever win the race at the first place, so there are 7 possibilities for that. Yep. So if 7 possibilities, so one person is being chosen. So then to come at the second place or winning the race in the second position or second place, how many people are left over? So 6 people will be left over. So we have a number of ways to choose a person, so which is 6. And then since this first place and second place is occupied, so then for the third place, so it can be any one of them out of the remaining 5 people. Okay, here, how many ways can you order a white chocolate or yellow cake with chocolate or vanilla icing and 20 possible designs on top? So first of all, you have to think again what kind of problem this is. Are there different categories or not? Does the order matter or not? So what is your answer for that? Okay, this uses the counting principle because there are 3 different categories involved: the type of cake, type of icing, and the type of design. So since you remember, so here like in terms of cake, so there are three possibilities, and then icing there are two possibilities, and then the type of design there are 20 possibilities. So the total number of possible outcomes we can get is 120. Okay, try this one. How many ways can you arrange 3 sweaters in a display window from 8 sweaters? Again, first you're going to decide whether the order matters or not, then you will be calculating. So what do you think? Okay, it is a combination because the order of sweaters in the window does not matter. Yep. So we did not declare which order we're going to place. So it doesn't matter. So it can be a combination. So it's 8 factorial over 8 minus 3 factorial times 3 factorial. So again, we simplify it and we will get the total outcomes are 56 for this. Okay, so permutation counting principle. So there is example without replacement. So you are creating a password with 4 digits. You cannot repeat a number. How many possible arrangements are there? So since you know from 0 to 9 there are 10 digits. So start with that and each other digit will go down by 1. So if you're choosing a first digit out of 10 digits, so that means there are 10 possibilities. Then, so 1 is gone, how many numbers will be left over? So you have 9 choices left over. Then for the next one, for the next digit, you have 8 choices, and for the fourth digit, you have 7 choices left over. So this will give you the total of 5040 possible outcomes. Okay, here you can use these like the built-in probability functions in your calculator. So n factorial, npr or ncr, and rand returns a random value between 0 and 1. So you can explore more about calculator. And these are few common errors, so you can look into it. So make sure you do not confuse in npr or ncr. If the order is important, then is used. If it is not important, then ncr is gonna be used. Okay, if order is important, then you're gonna use permutations. If order does not matter, you're gonna use combinations. So remember, 0 factorial is 1, not 0. In particular, NC0 is 1. So we have discussed this in pure math too. Suppose you are making two different selections, say a 5 from a group of 10 and 6 from another group of 9. So the total number of ways is the product of 10 times 10C5 times 9C6, and do not add the expressions. Okay, then suppose R items are selected out of N. If repetition is allowed, then the number of ways is N to the power of R. If repetition is not allowed, the number of ways is NPR, and you should not be confused with this. Okay, hope this is clear to you. So you can practice few more questions because the examples we have discussed over here. So you can practice. Thanks for watching.